Okay, I was gonna say, I'm like, I'm on Discord on here.
Okay, yeah, you're live. I go live on YouTube, so live on YouTube.
All right, I can close. Can I close the YouTube?
Yeah.
All right, cool. Because I don't want to cause a reverb. All right.
Oh yeah, look, disable. Yeah, disable the waiting room.
Let's get it soon.
First, and then I'll run.
Click security.
Security.
Click
Uncheck that.
and then just click people. There are people in the waiting room still, so click view on the waiting room. Just click admit.
All right. That makes way more sense. I'm like, one participant can't just be me.
All right.
All right. Should be good.
Can
Can everybody hear me? I see the little volume changing up here, so it should be good. All right. Welcome. Welcome to the GitHub tutorial here, the GitHub workshop. My name is Alex. I'm a web developer. I've been a web developer for a little over a decade at this point. Use GitHub heavily myself, using GitHub for my job and then for various classes at the college and things like that. All right, guys. Thanks. Okay, so GitHub itself, this is an incredibly powerful tool. It's going to help you collaborate with your group members much more easily. It's also going to be very useful for the future for yourself for potential job applications and things like that. And it also just makes managing your code easier overall. I tried to put together a small little tutorial here, or like just some points basically that can help you focus down all the information that is available for GitHub, because it's an enormous product. There's so many things that you can potentially do with GitHub. I'm just going to kind of cover the basics here. I'm going to branch out a little bit from what's here as well because of what was mentioned at the beginning of the hackathon there by Major League Hacking. So I want to mention the Readme file and things like that as well. And in fact, this entire tutorial that I have here, it's made in a Readme file. So everything here is in Markdown. Markdown is a simplified kind of language that you can use to make things that look really good depending on how it's being rendered. GitHub by default uses this README file as the, I guess, default bit of text that's displayed on each repository folder. So I'll kind of highlight that a little bit as we go along here. So, okay, first things first, what is GitHub, right? GitHub is a version control system, more or less, right? There's a free version of this and free open source version of this that you can use locally on your own machines called Git. GitHub is built on top of that and just provides you like a cloud service so that you don't have to host your own GitHub or Git repositories on servers yourself or locally or whatever it might be. Instead, you can use this cloud service known as GitHub, where you can, and I forgot to capitalize that one H. You'll see I'll make changes as we go along here as well. You can use the GitHub cloud servers to host your code, not have to worry about hosting the code anywhere on your servers or anything like that. Collaborate with anybody much more easily, and it gives you a lot of nice tools when it comes to deploying code, taking website code potentially and making a website page out of it for free very quickly. Everything built into GitHub itself. So there's a lot of different tools that come from here, but the main portion of this is this idea of version control, right? This version control system. If I can kind of paint a picture for you that might resonate with some of you to draw your attention to using GitHub versus what you might be doing right now. Imagine you're working on your code, right? You're working on your code on the school computer, and you need to take your project home. So you zip up your project, you put it on a USB stick, you take it home, you put it on your home computer, you unzip it, move it into your downloads folder, whatever it might be, start working on your code a little bit more. And then you need to move it to your laptop or something like that. So you zip it again, put it on USB stick, put it on the laptop, unzip it, work on the code again. And then you need to take it back to school, zip it, put it on the USB stick, take it to the school, and then make sure that you have the right code when you're showing your teacher the code that you're using or submitting your code or whatever it might be, right? So all of that process, there's so many moments when something might go wrong, right? Where you have multiple unzipped versions of the folder on your computer and you're like, oh, which one was the one I was working on last? Which one has the right code? Things like that. All that organization process that you have to try to manage yourself by just moving code, bits and pieces of it by yourself physically, this can be eliminated by using this version control system known as GitHub. Instead of continuously moving your code back and forth on a physical device or sending it over Discord or whatever it might be, you instead just post it up to GitHub and you always have access to it from anywhere. You just log into your GitHub or you just download it directly from GitHub. So for example, this tutorial that I have here, this is all built in GitHub. I made a repository directly for this. And if I want to make any changes, I can change things directly here on GitHub, or I can look at the version of the code that I have locally on my machine. And as I want to make changes, like for example, this here, where I accidentally spelt this with a lowercase h and it should have been an uppercase H, I can make this change, go to my program and fix the spelling of my of the heading. I'll talk about all of the things that are involved here that I'm clicking through very quickly, but I can make changes. Oh yes, I have to log in first. I can make changes. I can push these changes up to GitHub and you can see these changes happen immediately, right? I just want to kind of be able to show you this happening live here at first so that you can see the byproduct of it very quickly, and then we can start to dig into how you can do all these individual pieces. So I can refresh the page and you can see GitHub understands I made a commit 28 seconds ago, and I can scroll down and yay, I have fixed my heading. Fantastic, right? And now I can go to any other computer and access this, or any of my group members can notice my change and pull the changes down to their local repository, so they always have the updated version of the code as well. Version control system. This is giving us access to the ability to collaborate with other people, to consolidate our code into one spot, and then we can also see various versions of our code directly here on GitHub. So I can go to the commit history here and I can see all the individual times that I made commits to the repository. If I want to get some of the code that maybe was previously on my repository, I can get it here from a commit history. And you can see, that sometimes there are messages left for you in a commit history where it's telling you, you might find a little Easter egg here of some kind, see some code that I might have been using for generating some of these links and things like that. So you always have access to every version of your code as long as you've committed it forward. You can always retrieve changes at any point in time, right? If you start to take your project and veer off in a different path and trying to use some new library, and you're updating your code and you're really investing a lot of time into getting this library working into your project, and then 2 hours down the line you have realized that this library is not going to work. All your code is not working now. It's very tied into that new library, and you are going to have to start from scratch with your code. If you're using GitHub, that is not the case, because every time you make a commit, you have access to that code at that point in time. So 2 hours down the line, something's gone wrong and you don't want to use that anymore, you can always go back to using the code at any point in time that was committed to GitHub. So a lot of the nice little benefits that come with using GitHub, just to kind of get started, right? Every time you want to store any kind of code here on GitHub, you make various repositories in order to kind of group the code into its own logical container, right? So you can see here, if I go to my GitHub repository, or my GitHub account, I should say, I have a few repositories here. I've done a few of the workshops here at MasseyHacks over the years, and I left the tutorials themselves as just repositories that are visible publicly. So if you want to go and look at any of the web dev stuff or the very old version of the GitHub repository workshop, you can go and view these. But each of these repositories is just its own logical grouping of the code, right? It would normally be its own project of some kind. So if you're working on a project, you just make a new repository for it, and then you store the code inside of it, right? So for example, this one, there were 13 commits across it. And then this was made, 4 years ago at this point, and I can see all the individual commits that were made to it. I can see all the little steps that were taken. If I was trying to learn some of the changes that were made here. I can click on individual commits and see, okay, so this commit says starting to add JavaScript to the tutorial, and I can see, all the individual pieces that were added at that point in time. So gives you a nice way to view the history and control the versioning of your code itself. It's the main idea behind GitHub, right? There's more description here, like some flavor text, but because we're on a time restriction, I kind of want to just move forward with the main concepts. Okay, so to get started, I did provide some links here. We're going to use a graphic user interface for this. We're not going to use the terminal. I know some of you will definitely like using the terminal instead. Power to you, right? You can use whatever interface you like to interact with GitHub. You can use Visual Studio Code. You can use terminal. You can use GitHub Desktop. You can use any other graphic interface that you might like, right? Git Kraken. I've seen a whole bunch of different programs. GitHub Desktop is just the easiest one, I would say. The most accessible for sure, because this is the one that GitHub themselves has made. They have distributed to us. They're constantly updating it, and it's generally pretty user-friendly overall, I would say, right? So we're going to use this variation. I've already got it downloaded, but you can visit the link there that I've added in the tutorial to download GitHub Desktop. When you install it, it's going to come with this program called Git, right? I mentioned that before, this idea of being able to like create your own repository or your own version control system locally on your servers or something like that. This is the underlying technology behind GitHub itself. So it has to come with it when you download GitHub Desktop, and you'll see there's a bunch of programs that come with it, like Git UI and things like that. So if you want to explore some of those, feel free, but we're just going to stick to GitHub Desktop and keep it simple for this tutorial. Once you've got GitHub installed, you need to connect your GitHub account. I already did that very quickly here, but let me go back and do this again just to take our time and go through these steps. So when you initially install GitHub Desktop, it's not going to necessarily look like this. There's just going to be a bunch of buttons over here that say like create new repository, clone from the internet, and things like that. But in the top left-hand corner, you can go to File, Options. This will always look the same, right? Whether you're in dark theme or light theme. And then you can sign in on GitHub. So in order to actually use GitHub Desktop, you need to have a GitHub account. You just go to github.com and you can sign up for an account. If you use your school email, you have the ability to apply for a pro account for free as a student. I have some links inside the tutorial that will guide you to being able to apply for that pro account if you're interested, right? There's a few benefits that come with using a pro account. They're significantly outside of the scope of what we're going to do here necessarily. But as time goes on and you're learning to use GitHub more, a pro account can be very, very advantageous. Something else to note, if you use your school email at first and later on you want to claim ownership of your GitHub account, but you've lost, you're not going to be using that school email any longer, that's okay. You can always change the email account on your GitHub account. So if you use your school email right now and you want to change it later, that's fine, right? You can always claim it on your personal account later, but you get the benefits of the pro account for the time being while you have that student email. So you'll need to sign up for a GitHub account. Once you've done that, you can go to GitHub Desktop, File, Options, and then over here, you're going to see a link that says sign in with GitHub. As long as you are logged into GitHub on the browser that opens by default in on your computer, when you click sign in and continue with browser, it will open a tab in the browser that just gives you a pop-up asking to reopen GitHub Desktop with the information that comes back from GitHub itself. I'm going to say okay, and there we go. The pop-up goes away. On the bottom left-hand side here, you can see my my user's avatar, I guess, the profile picture, right? So my little profile picture is now in the bottom left-hand corner here. Anytime I make any commits on any repositories, it's going to use my user to do so, right? When you're switching back and forth between users, you're going to sometimes see that this picture doesn't update and you'll have to handle that. But this tells me that I'm logged in on the right account. This is the user that's going to be making the commits. Fantastic. Now, when it comes to making your first repository, because again, this is not the view that you would normally see. I do have links throughout the tutorial here that'll lead to like visual steps that are given to us by GitHub Desktop or GitHub themselves. Oops, if I go back, where they have They have visual aids to kind of help you go through the process where this is what it would initially look like. You can create a repository directly within GitHub Desktop, and they walk through all the individual steps to make it through the program. I'm going to opt to do it just directly through GitHub itself, right? I'm going to make a repository with you just so you can see the process alongside me. So if I go to GitHub and I go to repositories, I'm on my profile, I go to repositories, I can click on new, name my repository something. So MasseyHacks, maybe all capitals, 8 example. The repository name needs to be unique across your repositories. So you can name it whatever you like, as long as it's not the same as another one of your repositories. Give a description of some kind, optionally if you like. This is the repository I'm using for the Zoom video. Now here you get to make a very important choice of whether you're going to make your repository public or private. If it's public, then anybody can view it and anybody can access it, right? So keep that in mind when it comes to your projects. If you're looking to just develop code for yourself, if you're doing your schoolwork and things like that, you're probably going to want to opt to make it private, right? For the sake of the hackathon, I imagine a lot of yours are going to be public because you want them to be publicly visible. You're going to be getting them scored and things like that, right? So they're probably going to be public. I'll leave mine public as well, so you have access to it as well. Yes, question?
Can we switch it from public to private?
You can. You can switch all the permissions on it whenever you need to. It's just a matter of in the time that you took to switch it to private, anybody could have potentially downloaded some of your code there. So you have to keep that in mind, right? But okay, I'm going to leave mine as public. I'll add a README and I'll talk about that README in a second. And just like they mentioned at the beginning of the hackathon here, there's a template for a gitignore file. I'm just going to leave it as none for now. We'll talk about the gitignore later, and then you can potentially add a license. I generally just choose no license initially, but if you are interested in choosing a specific license because you're looking to distribute your code in some way, you can Google some of the legal implications of some of these licenses, MIT and GNU probably being the most common, but I'm going to leave no license for the time being. Now, once I've chosen all my settings, I can create my repository. And there we go. Now I have this new public repository. If you again go and visit the MasseyHacks 8 repository that was linked to you on the website, you will be led to, let me go back here, you'll be led to this repository, right? And if you want to see my sample repository that I just made, you can always click on my username on the left-hand side here. Go to repositories. You will not see 21. You'll see like 4 or something like that. And you'll see MasseyHacks 8 example at the very top there. So this is the new repository. This is the one that exists on GitHub. I can make changes directly here on GitHub if I want. And for simple sort of things like updating the README and things like that, updating individual files, this is a great way to do so, right? I can click on an individual file, edit the file, make changes directly here. And when I make these changes, every time you change something to your repository, you're adding like a point on the timeline, right? Imagine that your entire repository is basically a timeline tracking what has happened to your code. So I'm adding a point on that timeline. I'm going to give it a little description to tell a future me or any student that might visit this repository in the future, they'll have better context as far as what I did on this individual change. So if I say added a message to YouTube in the README file, and I commit these changes, there we go. The repository has now been updated. GitHub.com has the changes. If I go back to the repository itself, you'll see the README file is what, again, is read by default on the repository, and everything is visible here, right? This file, this README file, this is something you can add to every folder within your repository itself. Every time you visit a different folder, it's going to try to look for a README file and then display it. Usually just have one, you have at least one on the main repository or the main page of the repository to help people understand what you're trying to do with your code, what your project does and things like that. If I were to try to draw some examples of this out in the wild, .NET GitHub, I'm going to pull from some sources that I personally, have vested interests in. So ASP.NET Core. Some of you know what this framework is. This is a backend framework for developing in C#. This has become an open source project at this point. So anybody can view the source code and contribute to it potentially and things like that. They have the entire code base here on GitHub itself. And if I look at just this one repository where they have the core functionality of the code base and I scroll down, there's a lot of files, of course, but there we go. There's their README file where they're starting to talk about and describe to you what ASP.NET Core is, how you can get started with it, how to engage and get feedback. These are the kinds of things that you generally put in your repositories, right? How people can use your library in some way, shape, or form. Whether you have documentation somewhere else or not, you can link to it, or you can just put the documentation directly in here. You'll see a lot of repositories just have documentation directly here in the README file because it's very easy to update, right? When you're working away on your project, you can always very easily, if I'm working on a website of some kind and I make some changes, whatever it might be, as I make changes, I can just quickly update the README file, post that alongside my changes, right? Documentation becomes much easier to do when it's all kind of consolidated into one place. So it's another aspect of using your GitHub repository. All right, I'm going to pull back here to what I had listed in the little tutorial here. I want to try to follow a certain flow. Mine was in the door actually. Thank you. Okay, so we got what we needed to get started. We have our GitHub account. We have GitHub Desktop installed, and now we can start to try to make changes to our repository. So I made the repository on the GitHub servers directly. I didn't make it using GitHub Desktop, right? So as much as this new repository, this whole MasseyHacks VIII example, it exists on the GitHub servers, it doesn't exist on my machine yet. I can't actually make edits to this repository on my machine yet because my computer has no idea has no idea that this repository exists yet. So if I go to GitHub Desktop, since I already have repositories here, my view is a little bit different. I have to click this side navigation to actually view different repositories. But if I want to add a repository here on GitHub Desktop, I can do it through that dropdown. I believe I can also do it through the navigation up here somewhere. Yeah, so here. So you can either add a local repository, create a new repository, or clone a repository. I'm going to choose clone because I already made the repository on the GitHub servers. I don't need to make a new one. It already exists. So if I choose to clone it, I can say MasseyHacks. And you can see here, there's the repository. Since I'm logged in on the same user, it sees all the repositories that I would normally see, right? If it doesn't show up right away, I would click this refresh just to make sure that it is the newest list of things. I can choose this repository and I will clone it. Now, what happens with this is there are two versions of the repository now that we are managing. The local copy on my machine and the copy on the GitHub servers, right? Local and then origin. That's the kind of verbiage that GitHub uses. So anytime I make changes to the repository on origin, so for example, if I were to go back to this file and I make another change of some kind, right? Let's say this. So I make some kinds of changes, making a change on origin, committing that change. Now, I made the change directly on GitHub. So of course, the GitHub servers, they see this change, right? Everything on the web reflects this change that I've made. But if I go and look at the code locally on my machine right now, so let me try to go and look at this repository's code specifically. Let me just open this in Visual Studio Code so we can kind of view it together. I will pull this in here. So if I go and look at the file that the version of the file that I cloned from GitHub itself, I don't see those changes, right? There was something changed in this README file. There was a header that was added. I don't see the change right now, right? Where's the change? Origin got updated. local didn't. For local to get updated, I have to go and I have to request, I have to ask the server, hey server, do you have any updates for me? So I fetch these updates. I ask the server, do you have updates for me? I click fetch, it checks, and the server responds and says, yep, there is one change. You can pull this change down to your local copy if you would like. So I click pull origin. And now it has pulled all the changes from the remote server down to my local machine. And now when I look at the code on my local, there we go, there's my change, right? So anytime I make a change, there has to be a communication between local repository and remote repository. Same idea here. If I make a change here, and I save this, Visual Studio Code is a nice editor when it comes to interacting with your GitHub repository code as well, because it does reflect some color scheming for whether a file is new or edited or whatever it might be. It highlighted in a little bit of a golden tinge because it noticed that I modified the file. But okay, we go back to GitHub Desktop. GitHub Desktop notices, it says you have made a change. This is the file that you have changed, this readme.md, right? Here is what it originally had on these lines that we are comparing. And here is the addition that you have made. I made an addition, so it shows up as green. Whereas if I had deleted something, so let's say I delete this, I'm going to delete the hi YouTube. It'll show it as red. So it used to be there, it no longer is. The left side is what it all used to be. The right side is what it will be moving forward once you push this up to the servers, right? So, okay, I've made this change. I'm happy with this change. I wanna actually put this change on the GitHub servers. In order to do so, same idea as what I did on GitHub. I have to write some sort of message that tells, you know, a future person that is going to look at the commit messages potentially what happened, right? This is the intention here with these messages. We're trying to inform anybody reading the code or anybody looking at previous commits, more or less what happened in these individual commits. So removed the YouTube message and added another header. Usually want to keep these commit messages quite short, but I'm just doing a brief example here. So I'll commit this. Okay, so I took the change, I gave it a summary of some kind, and I've committed it. Every time you commit a change, it updates the code on that copy of the repository. When I was committing things on github.com, it was committing those changes to origin directly because I was modifying origin directly. Here, I'm modifying my local repository. So I committed the change locally, but if I go to GitHub Servers right now and I refresh, nothing has changed, right? I don't see that local thing. I don't see that hi YouTube is gone, nothing, right? GitHub.com servers, as far as they're concerned, nothing has changed. It's because the change has only been made locally yet right now. I committed it locally. It doesn't go out to the GitHub servers. Oh, sorry. Until I click push origin. So there's those three parts: fetch, pull, and push. Fetch asks the server, or do I have any changes compared to what you have? Pull pulls those changes from the server down to your local machine, and push sends your changes up to the remote server, to origin, to github.com. So now that I've made that change and I've pushed it, I can refresh, and you can see my commit was 1 minute ago. So it noticed that I made the commit a minute ago locally. And then now it actually received it. And now I can see all those changes made here on the remote server itself. So we're maintaining two versions of the code in a sense, but it's all like, this is the version that we really care about, right? The version that's on origin, the version that's on the GitHub servers, the one that's on the remote server. That's the one that should be the master copy, right? Every time we make any changes, we always commit and push them up to that server. That way everybody can see those changes happening and they can pull those changes down for themselves. All right. So we kind of flew by a lot of these things. We made our first repository. We cloned our repository down locally. I've talked about this idea of local versus origin, and I want to highlight another piece of that. So you'll notice here, I actually can see a hidden file here. So if you go on Windows machines, if you go under View and you check off hidden items, this is a great thing to do actually as a developer as well in any language really, because there's a lot of hidden files that come with our IDE and things like that, right? So GitHub provides another hidden folder of some kind. This .git folder is what's telling GitHub Desktop or any of your interactions with GitHub locally that this is tied to a specific repository, and these are the current changes that are there. Without this, if I delete this folder by accident or whatever it might be, and I go back to GitHub Desktop is now very confused and says, I don't know where your folder is for that code. I looked for the .git folder, I didn't find it, so I don't know where your code is. Please go find it, right? So if you ever move your folder, it's going to do this, and it's going to say, hey, go find the folder that has the .git folder in it. Or if you accidentally delete it, it's going to happen as well. So I'm going to undo the change so it actually comes back. Go back to GitHub Desktop and it checks again and says, oh, okay, good. We got the .git folder. We understand how to track all these changes. So that's one part of it. The other part is that anytime I add files or folders, or not necessarily folders, but anytime I add files or change files or anything to any code inside this folder, the one that contains the .git folder or any folder deeper. So if I were to, for example, make a new folder, folder changes, I guess. So I can make a folder. GitHub doesn't really understand what folders are by itself, but as soon as I add a file within that folder, so let me go back in here, I'll add a new file. I'll add a readme.md. And I go back, ooh, it notices that. And it notices that it is within a certain structure, right? It's like, yeah, you apparently added a readme.md file. It's inside of folder changes. When you push this up to origin, it will maintain that folder structure for you, that folder integrity. So if I go into Visual Studio Code, just to kind of view this file very briefly for myself and be able to make some changes. First off, I want to be consistent and make everything the same case. This is a second README file inside the folder. So I can add some kind of message. I'll add my summary so that I can actually push this up to GitHub and know what happened. Added a README inside of the folder. Commit. Successful commit. I need to push to origin in order for it to actually be on the GitHub servers. So I push to origin, wait for it to finish. Okay, great. Now I can go to the GitHub servers, go back to my repository that I was viewing, right? Refresh. Commit made it 16 seconds ago. There's my folder. And if I click on it, it has a README inside of it. And like I said, the readme.md is red. Anytime you visit any folder, that's what's by default displayed down below, right? So now I have everything set up so that I have a folder. Inside of a folder, I can make changes to, if I make changes to like the folder name, it's going to affect it. If I add files in here, if I delete files in here, everything that I do within this MasseyHacks 8 example folder is going to be stuff that GitHub Desktop notices. And once it notices it, you can choose to commit and push it up to the server and keep track of all these changes that you make to your code. And not just code, you can put images and stuff like that. Probably best to avoid putting files that are too big. I know there's a size restriction on how big you can put, how big of files you can put on GitHub by default. But I think it's like 100 meg or something like that, which if you're putting a file that big, you should consider a different tool to begin with. Okay, let me just go back here to the tutorial itself. So we made our commit. We talked about this idea of committing locally and then making sure that you actually push up to origin, right? This idea of fetch, push, and pull. You're going to be using these all the time, especially when you're collaborating with other students, right? You're going to be pushing things up to the server, and then your classmate's going to be pushing something up to that server on the same repository, and you will have to fetch to make sure that you can actually pull their changes down to your version of the repository locally, right? No longer have to email code to each other, send a file over Discord, anything like that. No. You are all connected to the same GitHub repository. You push your code changes to the repository and you tell the other person, okay, you can pull the changes down now, right? You can collaborate much more easily together this way. Being able to browse the history and understand how the history works is very important and very useful, I should say. So you saw a few times I've actually gone through and clicked 5 commits and I've looked at all the individual commits themselves. If you click on any of the headers, it'll just show you what that commit did in that one instance in time. So what was previously there and what is there now based on that commit. You can also go a step further and you can click on this button on the far right-hand side of any of these, and you can see what the repository was like at that moment in time. So you see, I clicked on one of the commits before we made that folder, and it looks at the repository without that folder, right? I can see what the code looked like at exactly that moment in time. Okay. Let me just make sure here. It's not just about being able to view the overall commit history as well. You can view the commit history of individual files. So as much as the repository itself has 5 commits, if I were to go into this new README file and look at the history of this specifically, it just has 1, right? So when you notice that one of your files is suddenly, maybe it has the wrong code in it, maybe somebody deleted something accidentally and it's missing now, or whatever it might be, but it was 50 commits ago across the repository, that's going to be a problem to potentially find. But if it was just like 1 or 2 changes that have been made to this file, you can now just look at the history of individual files and you see a much more condensed version of the history overall, right? It only shows you the history of commits that affected this specific file itself. So very useful when it comes to trying to find some of the code that you may have lost over time. All right. Branches is probably one of the other big concepts that we definitely need to cover here. So we have this version of the repository, this version on this main branch, right? Usually, if you think about this in the context of imagine like a website that has like the code, the version of the code that's working currently that users are interacting with and things like that. But of course, if you're developing something, you're continuously trying to add new features and you're trying to build new things. You don't want your users to see those new things until you're done. You want them to be, you want to be able to work on them without affecting what the users are seeing on their machines. Ooh, can somebody actually unplug the power for my thing and plug it back in, please? Because it's going to die soon. Thank you. Okay, so when you're making changes, when you're fixing bugs, whatever it might be, you don't always want to affect the version of the code that is in production, right? That's the kind of verbiage here. You have like a production version of your code, and then you're trying to work on fixing bugs and creating new features separate of that, right? You don't want to affect the production version of the code because that's the stable version. So if you want to develop a new feature, you want to fix a bug of some kind, you do it in a separate branch. What a branch is essentially just a copy of the code or a copy of the history of the code that is separated off. It is its own entity within the same repository. So for example, if I go here at the top where it says main or current branch main, I can click that, create a new branch from here and say, example, feature, name my branch in some way that's logical based on what I'm trying to do. Branches are just like commits. When you do something locally here on your GitHub desktop or in Git Bash or whatever it might be, the creation of that branch is only localized to my local repository unless I push it up to the servers. The pushing process is actually called publishing when it comes to branches. So you're pushing the branch up, you're publishing the branch. So if I publish the branch, now it's going to be available on the GitHub servers as well. And before we go and look at it on GitHub itself, I'm going to go and look at the IDE where everything is exactly as it was, right? As far as the code is concerned, I haven't done anything, but I can make a change here. Maybe I'm going to add like a new folder as a feature, right? I'll move the folder afterwards. New feature. We'll move it out. I'm going to keep on adding more README files because apparently that's what I'm focusing on here. So I'll make another README. Check out this awesome new feature. We'll fix the H. I won't save these changes. So added a new folder, added a new README, right? I'm going to make these changes and commit them to GitHub, push them up to the actual GitHub servers themselves, adding a new feature README file. committed locally, push to origin. Okay, let's look and see what happened here. If we look at the folder, I go back, folders here, new files here, makes sense. I'm editing it all locally on my computer itself, right? If I go to the GitHub servers themselves, and I look at what I was looking at previously, no change, right? Because I'm on the main branch. The main branch I didn't make a change to. I actually went and made a brand new branch, and that's where the changes are stored. So if I go to that branch, there it is. There's my change that I've made. This is a variation on the code, right? So any changes, any edits I do, anything I do within this branch, they are isolated to the branch itself. They will not affect the main branch until I try to push that kind of code into the main branch later on, right? So you can have like another instance of your code where you can make changes and you can add things and you can play around with new libraries or something like that. And if it works out, great, you can potentially bring it into the code itself later or something like that. You can work on separate projects together within the same repository, right? Somebody's building the Stripe integration on the website, they have their own branch for it. Somebody is trying to make the contact form on the website, they have their own branch for that, and they can work on their own isolated copies of the code so that nobody is causing trouble for the other person on the same code base when they're pushing things up to GitHub itself. This is a great way to be able to develop new features without breaking the main version of the code and affecting everybody on your team necessarily, right? Now, locally, if I want to go back to the main branch, I can always click here, switch back to main, and what ends up happening is my folder gets updated and only contains the items that are on the main branch. That doesn't mean I lost that new folder and that README. They're just on a different branch. If I want to see them locally on my machine, I just have to switch back to that original branch or that other branch, and there we go. They come down with it, right? So every time you switch branches, the files themselves change. They're based on that version of the code. I'll just stay on main. All right. Anybody have any questions, by the way, so far? Any chat? Great. Okay, so I showed the idea of switching branches. That's the main foundational piece, I would say, for GitHub itself. But for the context of the hackathon itself, I imagine this one is actually very, very important as well, inviting people to collaborate, right? So if you want to actually invite your classmates or your group members to your repository to collaborate on the same code together, somebody makes the repository and then they go to settings, collaborators, they'll have to enter their password, which I don't necessarily want to do here live. So instead, I'll just show you the link that I had in the repository itself. Let me go back to, the great thing is that GitHub and GitHub Desktop, they both have wonderful documentation listed with a lot of visual aids and things like that. So I have a link to how you can actually add collaborators. You go to settings, you will go to collaborators on the left-hand side, and then you'll have at the top right, invite collaborator. You'll enter the username of your group members. You can invite them to any kind of permission level. They can edit, or they can view, or they can contribute, or all these kinds of things to be able to control who can make meaningful changes to your repository. But the default, of course, you just want them to be able to edit and contribute just like normal. So this way you can all work in the same code base. You're not having to all have individual repositories and again, just cross-reference your code and things like that. There's a lot more when it comes to GitHub itself. There's a lot of features that you might end up using, such as merge conflicts, right? Sometimes two of you are working on the same exact code and like the same file, for example, somebody pushes their changes up and then somebody else tries to push their changes to the GitHub servers and GitHub says, oh, you can't do this yet because somebody else has changed this file as well. You need to make sure that your changes and their changes aren't going to conflict or create problems. So GitHub gives you a way of doing that built in, right? And it actually tries to resolve a lot of conflicts for you automatically. So unless you've both edited like very complex code in the same spots or something like that, generally speaking, GitHub will actually resolve the conflicts for you by itself. But if it doesn't, then you have to go through the merge conflict process. And there's a lot of tools for that. And that's more of a complicated process. If you need help with that, just let me know and I can kind of walk you through that individually. The last kind of thing here that I will add, because this is going to be very relevant for a lot of you, especially if you're using custom keys of some kind or databases and things like that, where you have files that have sensitive data inside of them or whatever it might be. So let's say, for example, I had a file here that was like dbinfo or db.info, something like this. Let's say I had this file and I was saying the password is very secure password, right? So I have this database password file. I need it locally on my machine in order to be able to run the application locally. But to have this on my GitHub repository, especially a public one, that's dangerous, right? I don't want people to be able to view this file. I don't want this information on my GitHub repository, but I need it locally on my machine for it to work, and it needs to be here. So in order to enable this, you add another file in your repository called .gitignore. The .gitignore file will list a bunch of file names or folders that you want to be ignored when you try to make GitHub commits. So let's say, for example, I wanted to ignore the db info file. I can add it here to my git ignore, and you'll even see, like I said, Visual Studio Code is very good at highlighting things in colors for you, telling you what's going to be added. db info was green because it was going to be added originally, and then it read my git ignore file and it said, oh yeah, we're not going to add this file anymore, right? So it still gets to stay in the repository folder, and I still get to use it for my program, but it doesn't go to GitHub, which is great, right? Great for enabling a little bit more security for yourselves. And this would end up being like the only file that each individual person working on the project has their own version of that file locally, right? You have your own connection to the database or whatever kind of sensitive information it might be, right? To avoid putting sensitive info on the repo. So I committed, I pushed. If I go to my repository itself and I refresh, I can see the .gitignore file was added, but the dbinfo file was not added, right? This is also very useful when it comes to large libraries and things like that. For those of you that are using Node.js in some way, or NPM packages or whatever it might be, there are certain files and folders that you genuinely don't want to be put on GitHub because they're enormous, right? You don't need all libraries from NPM to be added to your GitHub repository. They should be able to be easily installed locally based on certain files that you have, right? So files and folders that would be huge, like node modules, for example, these would be great candidates for things to add to your .gitignore, because this is like unnecessary files that would be added to the GitHub repository. They just make it bloated for no reason. And every time you make updates, it's going to cause problems. These kinds of standard libraries that come from NPM, or if you're using Yarn or whatever it might be, these are things you don't want on the repository. They just make a mess, right? Same thing for generated files, right? If you're creating a .NET application or something like that, where there are certain files that are being generated automatically when you compile. So your OBJ folder, your bin folder, anything that's auto-generated by running the application, these are generally things you don't need on the repository. They might be hyper-specific to your machine. So if somebody else downloads your repository, it's not going to work for them, right? They don't need these files and folders. These are all examples of things that you would add to your .gitignore, so that they don't go up to the GitHub repository and they don't cause these problems for all your coworkers or your group members, I should say. Okay, and I think that's pretty well the main part of what I wanted to talk about. Oh, one last thing, because I know this is going to be something that a lot of you are going to be interested in, actually. So a lot of you are doing website stuff, right? You're looking to host you're looking to make a website, host it somewhere potentially, and establishing some kind of hosting can sometimes be complicated, or you don't need it to be very, very verbose or anything like that. You just need to be able to do a very basic website because you have like an index file on your repository, right? So I preemptively did this over here on the MasseyHacks tutorial. repository, I made a branch here that says website sample. I grabbed a website sample from this bare bones website. You can visit it if you like, but it just has a basic HTML file with some responsiveness built in and some CSS and things like that, right? Just a bare bones website, nothing fancy, but maybe I want to actually have this website visible online without having to, sign up for some kind of hosting site and set up my URL and domain and all these sorts of things. No, I just want to take what's in my repository and just see it work live. There are a bunch of ways you can do this, but one of the tools that's built into GitHub itself is this GitHub Pages. So if you go to the settings of your repository and you go to Pages, you have access to choosing a branch that you want to use for the website that will be generated or that will be accessible on your on the link that they generate for you. So I choose the website sample. That's the one that has an index.html on the root directory. I could also go into other directories if I need to, but I put the index file on the root. I'll save this, and GitHub Pages doesn't necessarily tell you a lot of information about whether it has been posted or not, or if it's live and accessible just yet. The only information they really give us out the gate is if you see this banner as blue and it just has the little information icon, it's still working on deploying. But if I refresh and I continue to refresh, eventually this banner will be changed to a green banner with a check mark. And once that's happened, that means that I am good to go. I am safe to go and visit this link and it will have my new code on it. So I'm just going to kind of keep refreshing. Of course, this is not a prioritized thing on the GitHub servers. This is a free service they're providing for us. So it might take, a couple minutes here potentially, but you can make changes to your website and it will automatically be deployed to this URL that's auto-generated based on your username and based on your repository name. And you don't have to do too much extra, right? So there we go. It's deployed successfully. I can actually go and visit this link now. And if I do so, there's my bare bones website, right? So now I have a website pulling code from my GitHub repository, and I don't have to do very much else to be able to update this and make sure it works. I just keep pushing code to GitHub, and I wait for it to deploy. And once it's deployed, I have access to it directly. You can also take your domains that you're getting for free, and you can have it so that they are being used here. So you can, instead of having it as this longer GitHub IO link, you can just have your custom domain and it will point to that GitHub hosting as well. So for simple websites, this is great. I believe you can actually even host like React and Angular applications directly here as well. Just a little bit more work to kind of get it working. I think that's a pretty good start. There's so many more tools that are involved in here. Pull requests and deployment, and there's so many little things that you have access to in GitHub for free, right? Microsoft bought it and they made the free account much more powerful for us. You can have as many private and public repositories as you want now for free on your account, and with your pro accounts you can do even more. Sky's the limit, really. If you want to have some kind of integration with your GitHub repository, so you can just always access the code from there and store the code there and have it work somewhere else, there are all kinds of tools to make that happen, right? Just kind of make sure that there's nothing else I kind of wanted to touch on here. Any questions? Anybody got any? Cool, great. Yeah. So there you go. So you should be able to use GitHub now with your group members. This is a great way to store your code. And for anybody thinking about like long-term future ideas, your more and more, I would say your GitHub repository is something that employers are actually looking at, like your future bosses and things like that. Developers love seeing the kinds of things that you're programming, the things that you're interested in programming, your passion projects and things like that. It really gives more information to a future employer about the kinds of things that you're doing with your time, right? The kinds of code that you're writing in your spare time or for classes, things that you're learning, right? You can put it on a resume and say that you understand it, and you can also put it on GitHub and show you understand it, right? So, food for thought. All right. Thanks for coming, everyone. And for those of you on the VOD, I hope this helped.
All right. Thank you. Thank you. Well, yeah, I think.